Hi, my name is Jessica Mao and I'm with the University of Texas at Austin. Today we're going to talk about the importance of conceptual understanding in mathematics instruction. So what is conceptual understanding? It is defined as a measure of the quality and quantity of connections that an idea has with existing ideas. So think about all the mathematical topics that we know. Think about all the connections between these topics and how rich these connections can be. For example, think about the term decimals. We probably have a lot of ideas and a lot of examples for decimals, as well as how they relate to fractions and percentages. So maybe now we're starting to compare and contrast decimals with fractions and percentages. What we're doing here is that we are making connections and exploring our own conceptual understanding of a mathematical concept, which is decimals here. So now that we know what conceptual understanding is, let's talk about why it is important. The National Research Council defines mathematical proficiency in terms of 5 interrelated strands. They are procedural fluency, conceptual understanding, strategic competence, adaptive reasoning, and productive disposition. So all 5 of these strands are important on their own, but if we put them together, then they help us define and characterize a student who is mathematically proficient. So here we see that conceptual understanding is on the list as it supports the development of all these other strands. So for example, when we have conceptual understanding, then a procedure will help probably make more sense as to why and how it works. And if we have conceptual understanding, then it helps us choose and evaluate strategies that could help us arrive and solve problems. And conceptual understanding also helps reinforce our reasoning as to whether or not an answer makes sense when we solve problems. And finally, conceptual understanding makes us more likely to see mathematics as valuable and connect them with real world. And that pretty much leads to a productive disposition toward mathematics. So the National Council of Teachers of Mathematics, or NCTM, also describes conceptual understanding in terms of learning opportunities that our students get in the classroom. I've highlighted here 3 of them because they specifically relate to developing conceptual understanding. So the NCTM says that all students should have the opportunity to acquire conceptual understanding. That is, to understand the underlying math concepts to problems. Teachers should also provide opportunities to connect new learning with prior knowledge. We want to develop intentional connections between past learning and present learning. Finally, teachers should provide opportunities for students to engage with challenging tasks. One aspect of challenge or rigor is making sure that the students is not just understanding, but also able to explain the underlying concept of the math problems that they're working on. So let's look at an example that highlights the difference between conceptual understanding and rote memorization. Here we have 37 plus 28. Many students might be able to solve this accurately. When that's great, that's awesome. But what is also important though is what the student is thinking about when it comes to this problem. So one thing that might come to mind is that this is a combining situation. We're really trying to understand what students understand about the concept of adding. Perhaps the students can't compute this accurately, but maybe they could talk about what it means to combine different quantities. The problem could also be represented in multiple ways. While it is interesting to look at the different strategies that students use, what is most interesting is what their strategy represents about their thinking. Meaning, what do they know about this mathematical concept? So one student might create 37 tallies and 28 separate tallies and then adding them all together one by one. Another student could also represent this problem on the number line, and the third student might represent this problem by placing it in the real world or the word problem. One student might even make this observation that you can take 37 plus 28 and represent it as 30 plus 20 and then plus 7 plus 8. This gives rise to all sorts of interesting questions like, why does this work? Are there other number combinations that we could break this problem into? Or could we move these components around like this? 30 plus 7 plus 20 plus 8. Does that still work? So we might ask students if it worked for any operation or just addition. Finally, we might have a student who struggles with computation. So instead of computing accurately, the students might say, well, I'm not sure what 37 plus 28 is, but I know the number will be greater than 50, or that the number is somewhere less than 70. All this information is helpful because it takes what would otherwise be a simple problem and expands it to reveal what students understand about the underlying mathematical concept. Thank you for watching this Thayer Taylor video. Check out other videos in the playlist for teaching strategies that promote conceptual understanding.